Okay, so for number 66, we need to solve for x. So the first thing I need to do is get rid of the denominator. I need to find the common denominator. So let me come over here to this side and rewrite my problem. So I'm just going to sort of space it out because I like to write the common denominator next to each one. So like my common denominator is going to be x squared. So I'm going to be multiplying all three terms by x squared. And the reason why I like to do it like this is that way I can cancel things. So for this one, nothing cancels, so I'm left with 2x squared. In the second term, an x will cancel, so I take away one of that. So then I'm left with 5x. And then here the x squared cancels, and I'm left with 3. Now what I'm going to do is get this into standard form, and then I'm going to see if I can factor this. Now, it doesn't matter which technique you use because it's quadratic. You can either do factoring, quadratic formula, or completing the square. For me, factoring is always the fastest way. Now, these are easy enough where I'm going to guess and test on this one because the factors of 2 are just 2 and 1. And then the factors of 3 are 1 and 3. However, I just need to make sure that I have my factors placed appropriately with the correct sign because they need to be different. And the way that I need to check this is quickly do outer and inner and make sure that it does give me the -5 that I need in the middle, which it does. So I did get lucky here, and I guessed and tested with the right answer right away. So now I set it equal to 0, set each factor equal to 0, subtract 1, divide by 2, x equals -1/2, add 3, x equals +3. These two solutions do not make any of the denominators 0, so I'm good. The next one is going to be number 68. For this one, I'm just going to treat this as a proportion. I'm just going to go ahead and cross multiply here. And I could multiply this times this and this times this. So then I'm left with 13x. And then I have to distribute the 2 to this whole thing. So it's really going to become 2 times x squared plus 10 becomes 2x plus 20. I'm going to move the 13 over so I can set my polynomial equal to 0. So now I'm left with 2x squared minus 13x plus 20 equals 0. I'm going to go ahead and factor this one. This one I'm going to probably factor by grouping because I'd have to go through the factors of 20, which are 1 and 20, 2 and 10, 4 and 5. So instead, I'm going to do grouping. So I'm going to go ahead and multiply this. I'm looking for factors of 40 that give me -13. And those factors are going to be -8 and -5. So again, I write the 2x squared, replace the 13 with the 2 factors I just found. It doesn't matter the order that I write them in here. Put the 8x here, the 5x here, and then the 20. And now I make my groups. I'm going to factor GCF out of each group. 2x, x minus 4. GCF here will be -5. Because remember, what our goal here is to make these two things after we divide the same. So then I take the 2 GCFs, put them together, and then what was in common, write it once, set each of the factors equal to 0. I'll go ahead and add 5. 2x equals 5, divide by 2, x equals 5 over 2. Here I'll add 4, and x equals +4. So again, neither of these make the denominator 0, so they're both good solutions. The next one, Did I skip 60? No, I did 65 yesterday. Okay, next one is number 69. Oh, that one looks a little intense. So let me go ahead and write it over here. X, and I'm going to leave a little gap so I can put what my common denominator is next to each thing. Plus 3 equals 2 over x squared plus 2x. So the first thing I'm going to do is factor this denominator over here. Factor out a GCF of x, and I'm left with x times x plus 2. If you try to make the common denominator all three of these things, you're going to be left with a massive mess. So this is where it's important that the red is the common denominator. And that's what I need to multiply each piece of this problem by in order to eliminate the denominator. Now, for the very last one, it cancels it out totally. So, but for here, the only thing that was missing was the x. So I'm doing x times x, I get x squared. For this one, the next one, it is missing the x plus 2 from the denominator. So that's what I'm going to multiply the 1 by, which just becomes x plus 1. Then the next one, it's missing everything. Now, we could actually put it back as the factored form and do it, or the unfactored form, and put it in here like this. And then the last one, it canceled, so it was just left with a 2. So now I need to distribute this one. So x squared plus x plus 1 plus 3x squared plus 6x equals 2. I need to start combining like terms here. So I have an x squared and an x squared. This becomes 4x squared. Then I have an x and a 6x. This becomes 7x. I've got the 1, but now I need to move the 2 over. So now I have 4x squared plus 7x minus 1 equals 0. So I'm looking for, right, so here was, I messed up here when I distributed it to this term here. This should have been a plus 2 here instead of a plus 1. So you see how one little mistake, and it's going to mess up your whole problem. So you got to be very, very careful. Okay, so then now when I move it over, this is actually a 2. And then now this is gone. So now I have 4x squared plus 7x equals 0. I'm going to factor out a GCF of x. I'm left with 4x plus 7 equals 0. Set each factor equal to 0. Subtract the 7. 4x equals negative 7. Divide by 4. And x equals negative 7 over 4. Now remember, because these are rational equations, we need to check to see if either of these zeros or these answers will make our denominator 0. And it will. Soon as I plug it into this one right here, it makes the denominator 0, as well as the last one. So I would remove this one, and my only answer is x equals negative 7 over 4. Number 71. This one we're going to do U substitution on. So for 71, the problem is 2x plus 3 raised to the 2/3 power plus 2x plus 3 raised to the 1/3 power equals 6. I'm going to set u equal to 2x plus 3 raised to the 1/3 power. So I'm going to replace this with a u and make it u squared. Same thing in the middle, equals 6. I now need to set my equation equal to 0. So I'm going to subtract 6. And now I'm going to see if I can factor this. And I can. It'll factor into u plus 3 and u minus 2. Then I set each of the factors equal to 0. Now, when I do this, this is giving me the value of u, not of x. So I'll add 2, and u equals 2. So now what I need to do is take what I had originally set u equal to, and I'm going to replace this right here for this u and this u. Let me come up here next to it. So I'm going to do 2x plus 3 raised to the 1/3 power is equal to -3. I'm going to do this one first. In order to get rid of that fraction exponent, I'm going to raise both sides to the 3rd power. Because remember, a power to a power, we multiply this, and this just becomes a 1. So this becomes 2x plus 3. And then -3 to the 3rd power is -27. Going to subtract 3. 2x equals -30. Divide by 2. And x equals -15. Next, what I need to do is do the same thing, but now I'm using the +2. Okay, so the next one, 2x plus 3 raised to the 1/3 power equals +2 now. Again, raise both sides to the 3rd power to clear that fraction exponent. And then you're left with 2x plus 3 equals 8, because 2 to the 3rd power is 8. Subtract 3. 2x equals 5. Divide by 2. And x equals 5/2. So your two answers are 5/2 and -15. The next one is number 73. So for 73, we're just going to square root both sides. So we have 4x minus 2 under the radical, 3x plus 1. In order to clear the radical, remember you're supposed to isolate a radical. Well, they're both isolated. So let's just square both sides. Squaring the radical cancels it. So now I'm left with 4x minus 2 equals 3x plus 1. And then now I will move the 3x over. I get x minus 2 equals 1. Add 2. X equals 3. And it works. So that is a correct answer. Next one, 75. Okay, so they're all going to be, the rest are going to be all odds. So 75, 77. All right, so I'm just going to go straight down the column. So 75, x plus 2 under the radical equals 2 plus x. So again, what we need to do here in order to get rid of the radical is I need to square both sides. Now, when I square this right side, I got to FOIL that thing. So the left side just comes out. But over here, this side, I'm really doing this. And you either write it twice and FOIL it, or you memorize the pattern. So if you don't memorize the pattern, you get first, outside, inside, last. Combine those guys. And I get 4 plus 4x plus x squared. So I need to get my like terms together and set this equal to 0. So 2 equals 4 plus 3x plus x squared. Subtract the 2 now. And I get 0 equals 2 plus 3x plus x squared. I'm going to rewrite it in standard form over here on this side. And now what I'm going to do is look for the factors of 2 that give me 3. And that's going to be 1 times 2 because 1 plus 2 is 3. Set each of the factors equal to 0. Subtract 1. And my two solutions here are x equals -1, x equals -2. And they both work. Number 77. Now you should be checking these and plugging them back in when it's radicals. I didn't check it on 73, but you should be doing the checks, but they all work. This next one, they're not going to work. So let me just show you how to do this next one. 77, x plus 3 under the radical minus 3x plus 10 under the radical equals 1. Now, whenever you're solving this, I can't just square each piece. I've got to isolate one of the radicals. Doesn't matter which. So I'm going to go ahead and add the 3x plus 10 to the other side. So then it's left with x plus 3 under the radical equals 1 plus 3x plus 10. Remember, you're squaring both sides. So the left side frees up. However, the right side, I got to FOIL that thing. So again, if it helps you to write it out like this 2 times so you can see it a little bit better, then definitely do that. So first gives me 1, outside gives me 3x plus 10, inside gives me 3x plus 10 under the radical. And then last, whenever you multiply a radical by itself, it's just going to free up. So now I have this one. So I get 2, 3x plus 10 plus 3x plus 10. I'm going to add these guys. I get 11. So this is what I'm going to write down here now. I need to isolate this radical. So the first thing I'm going to do is move the 3x. I get -2x plus 3 equals 11 plus 2 times 3x plus 10. Move the 11. -2x minus 8 equals 2 times 3x plus 10. Now, if you want to divide everything by 2, we can do this. So then I'm left with -x minus 4 equals 3x plus 10. And now again, I got to square both sides because I got to still clear the radical a second time. So then here, I got to FOIL this, or you memorize the pattern. Don't just try to square this and square this. You actually have to FOIL it. So then this becomes x squared plus 4x plus 4x plus 16. So then this gives me x squared plus 8x plus 16. So then now, let me write that here. This is now freed up. I now need to move my like terms together. X squared plus 5x plus 16 equals 10. Move the 10. X squared plus 5x plus 6 equals 0. Factors of 6 that give me 5. That will be x plus 2 and x plus 3. Set each factor equal to 0. Subtract 2, -2, subtract 3, -3. So then now you should always be checking these radicals. So this one I'm going to check to show you that it's no solution. So if I go back and look at how long this one was, this was really intense. So let me come back here. I'm going to do the check. The original problem was x plus 3 minus 3x plus 10 equals 1. So when I plug in first -2, this gives me 1. This gives me -6 plus 10. This gives me 1. This gives me 4. So then the square root of 4 is 2. So this, when I subtract, is -1 equals 1. This is wrong. So then now if I check the other one, and I'm still using this, but this time I'm going to plug in -3. So here I get 0. Here I get -6 plus 10. Here I get 4. I get 2. And again, here I get, oh, I did that wrong. That's a 9. Oops. That should have been a 9. And then that's a 1. And then instead here, this is a 1. Let me fix this. 3 times 3 is 9, or -3 times +3 is -9. So then this is the square root of 1, which is 1. And again, -1 does not equal 1. So again, this would be no solution. These are both extraneous. All right, next one is number 79.
Can I ask a question?
Yes.
Earlier on,
Yes.
67.
67. Did I do 67?
Yeah,
On this one or a different page?
different page.
So for 79, this one has x squared plus 3x, which is under the radical, minus 2 equals 0. So again, whenever you're solving this, you need to isolate the radical first. So I get this, and then now I can square both sides. X squared plus 3x equals 4. And now what I can do is move the 4 over. X squared plus 3x minus 4 equals 0. Factors in -4 that give me +3 are going to be +4 and -1. Solve each. This gives me -4, +1. Again, when I do the check, both of these are going to work when I plug it in. So you would have done -4 squared plus 3 times -4 minus 2, and see if it equals 0. So 16 plus 12 gives you 4. And then when you square root it, you get 2. 2 minus 2 is 0. So this one works. And then when you plug in 1, 1 squared plus 3 times 1 minus 2 equals 0. 1 squared is 1 plus 3 times 1 is 3. So this is 4. Square root it. 0 equals 0. Notice they both check. Number 81. 81 is a cube root. So 6 plus 2 under a cube root minus 4x under a cube root equals 0. Again, isolate the root. So this time we're isolating a cube root. So now I get 6x plus 2 under a cube root equals 4x under a cube root. Cube both sides. All that does is cancel that root. And then I'm left with 6x plus 2 equals 4x. I'll move the 6x over. 2 equals negative 2x. Divide by negative 2. And x equals negative 1. And again, if you plug it in, it does work. Let me just come down to the bottom. Let me just add a page. So I think what I'll do is just do all the way down to 95. All right. All right, so starting at 83, it has negative 9x is less than 4x plus 7. I'm going to subtract 4x. I get negative 13x equals 7. And then from there, I need to divide both sides by, oops, I need to keep this as an inequality. Divide both sides by negative 13. Remember, when you divide by a negative, the symbol is going to reverse. So it's going to be written in interval notation, all numbers that are greater than negative 7 over 13. And again, it's just the symbol that's greater than, so it's parentheses. So negative 7 over 13 to infinity. So if it wants it written as a simple inequality, you write it like this. If it says interval notation, you write it like that. Then number 85. This one is negative 5x minus 4 greater than or equal to 3 times 2x minus 5. So this symbol is going to have a bracket instead of a parentheses when I finally write the answer. Remember, though, infinities always get parentheses. So the first thing I'm going to do is distribute, rewrite this side, move my like terms together. I get negative 11x minus 4 greater than negative 15. Going to add the 4. Negative 11x is greater than negative 11. Divide by negative 11. Again, I'm dividing by a negative, so I need to reverse the symbol, and it becomes positive 1. And then again, less than positive 1, so negative infinity up to 1 with a bracket. Number 87, a nice compound inequality. So for this one, 5 is less than or equal to 2x minus 3, less than or equal to 7. This time, instead of just the left or right side, I need to do everything to the left, the right, and the middle. So first thing I'm going to do is get rid of the 3. I get 8 less than or equal to 2x, less than or equal to 10. And now divide all 3 pieces by 2. And then I get 4 less than or equal to x, less than or equal to 5. So this would be the inequality notation, but written in interval notation. This is going to be a segment if you were to graph it. So it's 4 comma 5 surrounded by brackets. Then number 89. This one is quadratic. So again, what I'm going to do here, this is where we do our x check thing. So 89 is x squared plus 3x minus 4 less than or equal to 0. So I'm going to factor it. I'm going to factor it as if it were equal to 0. So I would get x plus 4, x minus 1, because these are going to be my cutoff points. So subtract 4, add 1, x equals negative 4, x equals positive 1. Negative 4 and 1. I need to get a test point, so I'm going to use 0 0 is usually the easiest. It's located right here in between them. So I'm going to take my original and I'm going to plug in 0. So 0 squared plus 3 times 0 minus 4. I'm going to see if that answer is less than or equal to 0. This gives me a 0, a 0. Negative 4 is less than or equal to 0. This is true. So this gets a check, an X, and an X. So in interval notation, it's negative 4 comma 1. And because my original symbol was less than or equal to, I get brackets. So remember how to do these quadratic inequalities. This is where we have to do the X check thing. Same thing on number 91. So for 91, my equation is 6x squared minus 11x minus 10 is less than 0. So for 91, I'm going to do factor by grouping. Again, if you want to guess and test here, you can. So I'm going to multiply this. I'm looking at my factors of negative 60 that are going to give me negative 11. So my signs need to be different. My bigger factor will be the bigger one because that's the sign in the middle. So 2 and negative 30, 3 and negative 20. I'm still not at 11. 4 and 15. There's my magic combination. So again, rewrite the first term. Replace the 11x with the two factors I just found. And again, it's an equal sign because these become my cutoff points. So then GCF of the red is going to be 3x. GCF of the blue is 2. Again, remember your goal here is to make both of these the same, which it is, but then put these two together. And now I set each of these factors equal to 0. 3x plus 2 equals 0. 2x minus 5 equals 0. Subtract 2. Add 5. So here this is 3x equals negative 2. Divide by 3. And x equals negative 2/3. Here 2x equals 5. And x equals 5 over 2. So again, I'm going to add it to my number line, least to greatest. So the negative 2/3 here, the positive 5 over 2 here. So obviously one's negative, one's positive. 0 is located right smack in the middle. Use your original problem, which was the 6x squared minus 11x minus 10 is less than 0. Again, this becomes a 0. This becomes a 0. So really all you're doing is comparing negative 10 to see if it's less than 0, which is true. So check, x, x. So the final answer in interval notation, because it was a simple less than, is the order, or not order pair, there's two solutions. It's the interval notation of negative 2/3, comma, 5 over 2. So let's do number 93. 93 has x cubed minus 16x less than or equal to 0. So let's solve this as if it's equal to 0. Factor out a GCF of x. I'm left with x squared minus 16. And then it'll factor into x minus 4, x plus 4. And now I'll go ahead and add this to my number line. Negative 4, 0, and positive 4. Because again, remember, you're setting each one of these equal to 0. So once I solve each of these, those are going to be my cutoff points on my number line. And now what I need to do is do the check here. So this time I can't plug in 0 because it's one of my answers. So let me go ahead and plug in 1, and I'm going to plug it in, remember, to the original. So 1 cubed minus 16 times 1 less than or equal to 0. 1 minus 16 less than or equal to 0. Negative 15 less than or equal to 0. This is a true statement. Okay, so since 1 worked, put a check here. X, X, check. So in interval notation, our answer is going to be written as, and again, remember this is negative infinity. Infinity would be here. So we have from negative infinity up to negative 4. And the original symbol was a less than or equal to. So it's a bracket. And then I'm going to union that with the 0 to infinity. I'm sorry, the 0 to 4. Because it's this section right here and right here. Let's try number 95. This one's a rational inequality. So I have 3x plus 6 over x minus 5 greater than 0. So again, remember we're going to set the numerator equal to 0 and the denominator. Subtract 6. 3x equals negative 6. Divide by 3. X equals negative 2. Add 5. X equals positive 5. So let me add these to my number line. This time I can use 0 to check. And it's located in between a negative and a positive number. I'm going to plug in 0 to the original. So I have 3x plus 6 over x minus 5. So again, greater than 0. So this will become 3 times 0 plus 6. 0 minus 5. 6 over negative 5. This is a false statement. So the section where 0, so this is false. So this gets an X where 0 is located. Check marks go here. And now in interval notation, again, remember negative infinity here, positive over here. And again, it was just a simple original greater than symbol. So all parentheses. So negative infinity up to negative 2, union with 5 to infinity. Next will be number 97. Again, it's still rational. So we got fractions here. 3x minus 2 over x greater than 4. I need to move the 4 over. 3x minus 2 over x minus 4. And now I'll set it equal to 0. I need to get a common denominator here. So 3x minus 2 over x. And this will become minus 4x over x. And then I can add my like terms. And I'll add these two. I get a negative x minus 2 over x equals 0. Set the numerator equal to 0 and the denominator. And now solve for x. Actually, you know what? Let me just go ahead and add x here. Negative 2 equals x, and then x equals 0. So now these are my cutoff values. So negative 2 and 0. And again, this time I can't use 0. I'll go ahead and plug in 1. 1's located over here. So let me go back to my original. And my original is right here. So 3 times 1 minus 2 over 1 greater than 4. 3 minus 2 over 1. 3 minus 2 is 1. 1 divided by 1 is 1. This is a false statement. So over here where 1 is located gets an x. Check x. So the final answer is -2, 0. The next one is number 99. And number 99 has 3 over x minus 1 less than or equal to 5 over x plus 3. Remember, do not treat this as a proportion. So let me move this over. Subtract it from both sides. So now I have 3 over x minus 1 minus 5 over x plus 3 equals 0. I need to find a common denominator. It's actually going to be both of them. So this one gets the, x plus 3. And then this one gets the x minus 1. So over here, it'll become 3 times x plus 3. And then over here, -5 times x minus 1. And then this has x plus 3, x minus 1 on the bottom. So now let me go ahead and distribute and simplify everything down on the numerator. So 3x plus 9 minus 5x plus 5. Let me just simplify this right here. I get -2x plus 14, and then it has the denominator. So now I have x plus 3 on the bottom, x minus 1. Now set each piece equal to 0 to get off all my cutoff points. X plus 3 equals 0, x minus 1 equals 0. Subtract 14. -2x equals -14. Divide by -2, x equals +7. Over here I get -3. Over here I get +1. Let me add all these to my number line. Least to greatest, -3, +1, +7. I'm going to use 0 as a test point. It's located in this section. So again, my original was up here. So let's go ahead and plug in 0. So 3 over 0 minus 1 less than or equal to 5 over 0 plus 3. 3 over -1, 5 over 3. -3 less than or equal to 5/3. This one is true. So over here where the 0 is located gets a check. X, X, check. Let's go ahead and turn this into interval notation. So remember, any of the numbers that come from the denominator, they're always going to get parentheses. And then the 7, though it came from the numerator, it'll get a bracket going to infinity. Okay, so let's go on to the next page. And just a few problems here. We have absolute value inequalities that we need to solve. So let's go ahead and remember, whenever you're solving an absolute value, make sure it's isolated. So the first thing I got to do, remember there's 2 different cases. This symbol, to me, remember how I accentuated it? This is a less and or than. So less than, but I said to sort of make it sound like and. And then when it was a greater than, think of it as a greater. So it would be an or. So this one's going to be an and. So 2x plus 9 less than or equal to 3 and 2x plus 9. Flip the symbol and make it negative. Subtract 9. 2x less than or equal to -6. Divide by 2. X is less than or equal to -3. Do the same thing over here. -9. or subtract 9, negative 12, divide by 2, x is greater than or equal to negative 6. So again, if you think about it on the number line, negative 6, negative 3, and if you wanted to graph it and see it, but again, remember it's an and, so it's going to be in between. So it'll be a bracket and a bracket in between here. Because again, if you were to have graphed them, like if I graph this one, it would have been a bracket going this way, and then this one would have been a bracket going this way, and we only want to do the overlap where we see both red and green. So that's why the final answer was the blue. So again, in interval notation, you're just going to do negative 6, comma, negative 3 in brackets. 118, same thing here. 5x minus 8 less than or greater than or equal to 2. And again, make the two problems. 5x minus 8 greater than or equal to. So this is an or, because it's a greater. Flip the symbol, make it negative. Add the 8. 5x is greater than or equal to 10. Divide by 5. And x is greater than or equal to 2. Or, and let me finish this side. And then we have x is less than or equal to 6 over 5. So again, on your number line, 6 over 5 is like 1 1/5. So put the 6 over 5 here and the 2 here. So this one would have been a bracket going this way. And this one would be a bracket going this way. And again, it's an or, so it should be pointing in opposite directions. So again, negative infinity's here, infinity's here. So from negative infinity up to 6 over 5 with a bracket around that, but infinity gets a parentheses, and then a bracket around 2 going to positive infinity. And number 119, same thing, 7x minus 3, 4. So again, this is a greater, so this will be an or. So 7x minus 3 greater than 4, or 7x minus 3 less than negative 4. Solve each one. Divide by 7. X is greater than 1, or 7 less than negative 1. Divide. X is less than negative 1/7. So then now again in interval notation, well, let me graph it for you so you got a visual. So again, the negative 1/7 here, the positive 1 here. This one would be a parentheses or an open circle pointing this way. And then this one over here, parenthesis pointing this way. So again, in interval notation, again, remember negative infinity, infinity here. So negative infinity up to negative 1/7, all parentheses, and then 1 to infinity. Then number 120. We have 1/2 x plus 2/3 and absolute value less than 3. Okay, so let's take a look at 120. Looks like I'm going to go into this work right here. So let me move it over here. So what I need to do here is it's going to be a less and. So 1/2 x plus 2/3 is going to be less than 3, and 1/2 x plus 2/3 greater than -3. First thing I'm going to do is multiply the entire equation by the common denominator, which is 6. So once I distribute it to the first one, I end up with 3x. Here becomes plus 4, and then 18. And here I'll get 3x plus 4 greater than -18. So I'll subtract 4, divide by 3. X is less than 14/3, and minus 4. 3x greater than -22, divide, and x is greater than -22/3. So again, this is a segment. It's just as simple. It started out as a less than, so I will do -22/3 and 14/3. And again, if you want to see it on the graph, that one I'll do in purple, this one in red, and again, negative first, and then the positive. And again, the purple one would be all numbers that are greater than, all numbers that are less than 14/3. And then the red one, all numbers greater than -22/3. And again, the answer, the solution is the overlap. Then the next one, that was 120. Let's take a look at 121. This one is an equation. So 3x, this is 121, 3x plus 7 minus 5 equals 0. So the first thing you should always do is isolate the absolute value. So I need to move the 5 over. Three x plus 7 equals 5. And now I'll make the two problems. So 3x plus 7 equals 5. 3x plus 7 equals -5. Subtract. 3x equals -2. Divide by 3, and x equals -2/3. Over here, subtract 7, divide by 3, and x equals -4. So the two answers are -2/3 and -4. And then now number 122. And the problem is 7x plus 8 in absolute value minus 2 greater than 1. Again, remember, let's isolate first. 7x plus 8 will add 2 to both sides. Greater than 3. So it's an or. So again, what we'll do here is make the two problems, because this is still in absolute value bars. So 7x plus 8 greater than 3, and then 7x plus 8 less than -3. 7x is greater than negative 5. Divide by 7. And x is greater than negative 5 over 7. Here I'll subtract 8. 7x less than negative 11. Divide by 7. So x is less than negative 11 over 7. So again, on the graph, we'll put the negative 11 over 7 here, and then the negative 5 over 7. When I graph this one, it's going to be all numbers that are greater than 5 over 7, and then this one, all numbers less than negative 11 over 7. So in interval notation, again, negative infinity here, infinity here. So negative infinity up to negative 11 over 7, unioned with negative 5 over 7 to infinity. And the next one, 120, that was 122, 123. So 123 has 4x minus 12 greater than or equal to negative 2. Well, as soon as I see a negative number over here, and I already see my absolute value is isolated, that's a red flag for me. I need to stop and think about this. What's going to come out of this absolute value will always be positive, so this will always be a true statement. So I don't need to do any work here. The answer is all real numbers. So negative infinity to positive infinity. Then the next one is 124. So 124, 7 minus 2x less than or equal to negative 2. Again, red flag here. Soon as I see an absolute value is set to be less than or equal to a negative number, this tells me that the answer here is no solution, because I will never get a negative number out of this, and that's what would have to be less than or equal to negative 2. Okay, and then we also have 3 problems here down at the bottom, some more eye practice. So we have this C here. So here, 8 plus 3i squared. I'm just going to write it twice and FOIL it. So first gives me 64. Outside 24i, inside 24i, and last 9i squared. So I need to take care of the 9i squared. That'll become 9 times negative 1, which is going to give me negative 9. I'm also going to add the middle here. I get 48i, and then I have the 64. I can also still combine my like terms here, and 64 minus 9 is 55 plus 48i. Then the other two, simplify each power of I here. So remember, we're going to break it down into an I squared. So we're dividing 18 by 2, we get 9. Remember, I squared equals negative 1. And then whenever a negative number is raised to an odd exponent, it's just negative, so negative 1. Over here, this turns into a fraction. So I have I raised to the positive 27 power. And again, I'm going to break the I apart. I'm going to make it 26 and an I. And again, now I can change the 26 into I squared raised to the 13th power. And then times I. This will give me 1 over negative 1 to the 13th power times I. Negative 1 raised to an odd power is negative 1. and then I have the I. So now I'm at -1 over negative I. I'm going to move the negative to the top, and now I'm going to rationalize. Multiply top and bottom by I. I get negative I over I squared. Again, remember I squared is equivalent to -1. Negative divided by a negative gives me a positive I. And that is it for the chapter 1 problem in the review.